Welcome to the deep dive. If you're working with large language models, you know they're incredible at general knowledge, but getting them to be truly reliable in specialized fields, medicine, law, specific coding, that's a whole different ballgame.
Yeah, definitely.
It often involves feeding them specific documents through retrieval augmented generation, or RAG.
And the big challenge there is, well, information overload. You give the model a stack of documents, maybe some are helpful, some are, junk,
Right.
and you need it to pinpoint the exact right answer, grounded only in that provided text.
Standard methods, they kind of struggle here.
Exactly. It's a critical bottleneck for making LLMs useful in enterprise and specific domains. And the paper we're tearing into today offers a novel training recipe to tackle this head-on.
Ah, okay.
It's a research paper proposing something called RAFT, Retrieval Augmented Fine-Tuning.
RAFT, got it.
Yep.
So our mission for this deep dive is singular. To really unpack this RAFT paper, we're going to understand precisely what this training method involves.
How it differs from the usual approaches, and what surprising insights it offers about making LLMs expert at using domain-specific info, pulling only from the findings presented in this source.
Okay, let's unpack this then. We know LLMs excel because they've absorbed just a massive amount of general knowledge from the internet fire hose.
Right, that vast pre-training makes them generalists, but when you need accuracy within a very specific, often dynamic domain thing, and internal company knowledge or proprietary databases or maybe bleeding-edge research not seen during training.
Since they haven't seen before.
Exactly. That general knowledge just isn't enough. You need the model to work with new information.
In the standard ways we try to make them work with new information are RAG, where you give the documents right in the prompt for that in-context learning, or supervised fine-tuning, SFT, right?
Yep, SFT, where you train the model on question-answer pairs from the specific domain beforehand.
Okay.
Think of it like an exam, a standard chatbot using only its pre-trained knowledge. That's like taking a closed book test.
Okay, makes sense.
RAG, on the other hand, is like an open book test.
Right. You get the documents, the book right there, and you have to find the answer during the exam.
Exactly. And performance depends entirely on how well the model can use that book on the spot.
Which might not be very well if it hasn't practiced.
Precisely. And this paper zeroes in on what they call the domain-specific open book exam. The goal is to make the model an expert open book test taker specifically for a particular field or, a collection of documents.
Okay, so here's where it gets really interesting. The paper argues that just combining standard R or standard fine-tuning isn't truly preparing the LLM for this specific challenge. Is that right?
That's the core argument. If you just use R with the base model, it's like taking that open book test without any prior studying or familiarity with the specific textbook you're given. You have the information, sure, but you're not efficient at finding it or knowing what's important within that domain's context. You haven't learned how to use this specific book effectively.
So REA provides the book, but doesn't train the skill of using it effectively for that domain. Okay, what about standard fine-tuning, SFT, on domain data?
Well, standard fine-tuning trains the model on domain-specific question-answer pairs, which is like studying for the exam.
Right.
But often, this training doesn't require the model to practice using documents during the training itself. It might just learn to kind of memorize answers or patterns from the training data without developing the critical skill of referencing and extracting from external text in the moment.
So it studies the material, but doesn't practice the specific skill of taking the open book version of the exam, where it must use the text you provide, even if that text is noisy or maybe incomplete.
Exactly. That's the gap RFT aims to fill.
This is where RAFT comes in as their proposed novel training recipe.
Yes, RFT is designed specifically to fine-tune LLMs for this domain-specific open book setting, essentially, in-domain RAG. Its goal is twofold. Build domain knowledge and build robustness against irrelevant or distracting information that, inevitably crops up in retrieval.
Okay, robustness. So how is the training data structured in RAFT compared to, say, standard fine-tuning? What's different?
This is really key. Instead of just questions and answers, or even questions, docs, and answers without much structure, RAFT trains the model on data containing a question, a set of documents,
A set, okay.
and a correct answer that is not only derived from those documents, but also cites the specific text verbatim.
And the document set isn't just the relevant ones, right? I think you mentioned.
Crucially, no. The set of documents provided during RFT training includes golden documents, those that do contain the answer, and also distractor documents.
Distractors, okay.
Things that are irrelevant. This simulates the real-world RA scenario where retrieval isn't perfect. You rarely get only the perfect snippet.
So they're basically training the model to actively filter noise during the learning process itself.
Precisely. And the output format the model is trained to generate is also critical. It includes a chain of thought style reasoning process before the final answer.
Ah, see, okay.
Yes, showing its steps explicitly and incorporating verbatim citations from the golden documents using specific tags, like hashtag tag begin quote, hashtag and hashtag end quote, hashtag tag.
Training it to show its work and link it directly to the source text.
Yeah.
That feels significant. It's not just getting the answer, but demonstrating how it got it from the documents.
Exactly. And that chain of thought isn't just for show. The paper suggests it really improves the model's reasoning ability within the document context, makes the training more robust, too.
Right.
There's an example in the paper Figure 3 about the Oberoi family head office. It vividly shows this training format. The question, the mixed context documents good and bad, and then the structured output with the reasoning, the quotes, and the final answer.
Okay, yeah. Seeing that format makes it click.
Yeah.
It really makes you appreciate how specific this training is to the RAG task. But there's also that counterintuitive part you mentioned, but not always including the golden document.
Yes, this is fascinating. For a specific percentage, let's call it P%, of training examples, they include the golden document along with distractors. Standard setup.
Okay.
But for the remaining percentage, 1 minus P, they deliberately provide only distractor documents.
Only distractors.
Only distractors. And the model is still trained to produce the correct answer in these cases.
That seems odd.
Yeah.
For a method focused on using documents, training it when the answer isn't there. How does that help?
Well, the paper finds this mixing, including training instances where the correct source is missing, is actually beneficial for performance on the downstream RG task later on. It seems to tune the model's ability to balance using the provided context versus maybe falling back on its fine-tuned domain knowledge when the context it's given is poor or misleading.
So it learns when not to trust the documents as much.
Something like that. Then, at test time, the RAFT model is given a question and the top U documents from a standard RG retriever, and it uses its learned skills to find the answer within that context, citing as needed.
Okay, so with this pretty clever, somewhat complex training setup, how did RAFT actually perform when they put it to the test?
Right, the evaluation. They tested RAFT on diverse datasets representing different real-world domains. They used PubMed QA for medical questions.
Okay, tough domain.
Yeah. Hotpot QA for complex multi-hop questions based on Wikipedia, so more general knowledge but needing reasoning. And subsets of Gorilla API Bench covering coding API documentation, things like Hugging Face, Torch Hub, TensorFlow.
So a good mix. General knowledge, reasoning, and very specific technical domains.
Exactly. And they compared it to standard approaches.
Yes, the baselines included standard Llama 2 models. This is the base model, and the base model plus RAG.
Yep.
And also domain-specific fine-tuning, or DSF.
DSF.
Both with and without RAG. And remember, DSF here means it's fine-tuned on questions and answers, but not specifically trained to use documents during that fine-tuning process, unlike RFT.
Got it. So the results, Table 1 in the paper lays them out.
How did RFT do?
RFT consistently and significantly outperformed all the baselines across every single data set.
Significantly? Like, was it just a marginal improvement, or?
Oh, far from it. Compared to a general Llama 2 model combined with RAG, which is a pretty common setup people use.
Yeah.
RIFT shows massive improvements. We're talking gains like 35.25% on Hotpot QA and a truly remarkable 76.35% on the Torch Hub evaluation.
76%. Wow.
Yeah. It's drastically better at pulling the right info and, importantly, ignoring the wrong info, the distractors.
A 76% jump on a specific coding domain is...
Is it?
Well, it's huge. What about compared to domain-specific fine-tuning plus RAG? That sounds like it should be a strong contender.
It should, right. But even against DSF plus RAG, RFT still showed substantial gains, like 30.87% on Hotpot and 31.41% on Hugging Face.
Still really significant improvements.
Absolutely. And this suggests that standard SFT, while it builds domain knowledge, doesn't effectively train the model on that crucial skill of processing context and extracting details during the task.
The open book skill.
Exactly, which is precisely what RFT is training.
So RFT isn't just building domain knowledge, it's building the specific skill set for effective RAG in that domain. It's learning both things at once.
Precisely. It's learning the answering style and becoming a sophisticated reader of the provided text simultaneously.
So what stands out here is the paper then breaks down which parts of their training recipe were the most impactful. What were the key design decisions driving this performance? What really made RFT work so well?
Yeah, they did some good ablation studies. One of the single biggest takeaways is the power of that chain of thought reasoning we discussed earlier.
The COT part.
Including that step-by-step reasoning with citations in the training data significantly boosted performance.
How much impact did that specific element have? Do they quantify that?
They do. Table 2 shows gains of nearly 10% on Hot Pot QA and almost 15% on Hugging Face just by adding the COT reasoning during training compared to training without it.
15% just from adding the reasoning steps.
Wow. Yeah. The paper emphasizes that simply providing the final answer isn't sufficient. The structured reasoning process guides the model, helps it connect the dots, and makes the learning much more robust.
It teaches the model how to think through the problem using the documents, not just what the final answer is. That makes sense.
Exactly. Another crucial element, as we touched on, is training with those distractor documents.
Right, the noise.
Standard models often get confused or, generate garbage when irrelevant text is mixed in. RAFT actively trains the model to ignore the noise.
Did they actually test training only with perfect documents versus training with the noisy ones?
Yes, and the results were pretty clear. The paper found that training RAFT with only golden documents performed worse than training it with distractors included.
Worse. Interesting.
Yeah.
Figure 6 illustrates that optimal performance on datasets like natural questions and Hot Pot QA is achieved when training includes distractors alongside the golden documents. It confirms that learning to discern, to filter, is a vital skill taught by RFT.
That makes intuitive sense. You need to train, like you'll perform at test time, right? And test time will almost always have noise.
Absolutely. And then there's that truly counterintuitive finding about sometimes removing the golden document during training.
Okay, back to this one. It still sounds strange to me. Why would training without the correct information source ever help a method focused on using source information?
It's puzzling at first glance, but the paper found that including cases where the golden document is absent for a certain percentage of the training data, remember, P less than 100% actually seemed to enhance performance on downstream RA tasks. Figure 5 shows this across different datasets.
So it wasn't a fluke on one dataset.
No. While the optimal percentage, that p-value, varies by dataset, this mix consistently seems beneficial for in-domain RAG.
Any theories why?
The paper suggests it might force the model to learn a more robust strategy, maybe one that doesn't over-rely on the golden document always being perfectly present and correct. Perhaps it improves its ability to leverage its own fine-tuned knowledge when the retrieval quality isn't ideal.
So it's not just about having the source, but about building resilience for when the source might be noisy, incomplete, or maybe even missing entirely in the retrieve set.
Exactly. Building resilience. And speaking of resilience, training with distractor documents also made the RAFT model much more robust to variations in the number of documents provided at test time.
So if the retriever gives it 3 docs sometimes and 5 docs other times.
Right. Figure 6 shows it maintained its performance better when they changed the document count at test time compared to models trained only on golden documents. Those models were more brittle.
Okay, that's a practical benefit too. So bring it all together. What does this mean for making LLMs work better in specific domains? What's the big picture here?
Well, RAFT is presented as a highly effective training methodology. It's a recipe for turning general LLMs into reliable open book experts, specifically for domain-specific RA tasks.
It seems like it moves beyond just, slapping RA onto a model or doing standard fine-tuning. It really targets the actual skill set needed for that open book scenario.
I think that's right. The core novelty is training with irrelevant documents. That counterintuitive idea of incorporating the possibility of missing golden documents during training and generating structured chain of thought answers with verbatim citations, these appear to be key.
They build models that are accurate and robust when working with specific document collections.
Exactly. And the strong results across diverse fields, medicine, Wikipedia questions, complex coding APIs, suggest this approach has significant practical potential. For anyone looking to make LLMs trustworthy navigators of specialized information, this looks promising.
It prepares them to be expert readers and reasoners within their specific field's library, using the books provided.
That's a good way to put it.
Okay, so to recap the core idea, RAFT provides a powerful way to train LLMs to excel at using domain-specific documents in a RAG setting. It teaches them not just domain facts, but the critical skills of sifting information, reasoning step by step, and citing sources accurately.
And it does this even using some, let's say, unconventional techniques like training with noise and sometimes deliberately hiding the answer sheet during practice.
Training for the real-world complexities of retrieval, as you say.
Exactly.
All right, here's a final provocative thought for you, our listener, to consider based on one of their findings. The idea that LLMs trained sometimes without the correct source document ended up performing better in RAG tasks later. What does this seemingly paradoxical result tell us about the fundamental way these models learn? How do they balance processing external text versus using their own internal, fine-tuned knowledge when tackling a specific knowledge domain?
It definitely forces us to rethink what learning to use documents really entails for these complex models. It's maybe not as simple as we thought.
Something to chew on. Thank you for joining us on this deep dive.